The Center of Excellence in Safety Engineering and Analytics, CoE-SEA, welcomes all our dear participants to week 64 of the weekend talk in Safety Engineering, Management and Analytics. The event is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. Let's begin today with this beautiful slogan, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amritam Gamaya. Praying to Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Let me welcome the dignitaries onto the virtual dais. We have Professor J. Maiti, who's the chairman of the center, Professor O.B. Krishna, who's the convener of the event, and our expert speaker for the day, Mr. S. Gopakumar. Mr. S. Gopakumar is an electrical engineer and the managing director of Cape Electric. He has over 27 years of experience in electrical safety, lightning protection, EMI, EMC, etc. He has carried out over hundreds of site studies on failure analysis of electronic equipment and of electrical accident analysis, including various fire accidents from electricity, conducted more than 1,000 trainings in various countries on subject of his expertise. He is working as a consultant in several large-scale industrial and defense projects in the subject of safety and EMI, EMC. He has published articles about shock protection and fire from electricity in various magazines and has published the book, The Missing Link, in the subject of electrical safety. He is a technical coordinator of Lightning Awareness and Research Center, LARC, Trivandrum, and is currently the center has taken up mass movement in electrical safety called the Vaidyuti Surakshit Bharat Abhiyan, with the view to reduce electrical accidents in the country. CoE-SEA wholeheartedly welcomes you to this event, sir, and we are very privileged to attend to. Now I kindly invite Professor O.B. Krishna to officially, formally welcome our expert speaker.
Thank you, Sin. First of all, let me give my best wishes to all the participants on the occasion of Krishnastami. Today is Krishna's, Lord Krishna's birthday. A person who had shown great wisdom, great path to the whole of the mankind. Mr. Gopakumar is a great experienced person. He's a big industrialist, a great knowledge in the electrical engineering, and especially this fire safety in electrical engineering is a big issue. I always get concerned. Most accidents of electrical fire, or most fire accidents, are attributed to short circuits. Short circuit means the response will be taken by God, not the human beings, not the industry engineers. That is the perception. I don't agree. From IIT Kharagpur, we don't agree. My students are working in many interventions. Industry 4.0, IIoTs. How can we predict before any fire happens the weakness parameters of the systems? We are all working. So, Professor Mr. Gopakumar's today's talk will be very enlightening to all the participants. So, with these few words, I welcome Mr. Gopakumar again to this talk for accepting and agreeing to deliver this talk. Mr. Gopakumar, to you, sir.
Thank you very much, Krishnaji. Thanks for the center for giving me an opportunity to make a presentation in this gathering. So let me share my screen. I hope the screen is visible now.
Yes, sir. Yes, it is.
Yeah. So thank you very much for giving me this opportunity. I will try to cover the subject in a short time because the complete subject, if we talk, this takes several days. So I try to put a few important points which need a little bit immediate attention to reduce the number of accidents in our country. So before, as an introduction, so I'm a member in the TC64 of IEC. IEC stands for International Electrotechnical Commission, which is we have in India the Bureau of Indian Standards. The electrotechnical standards of Bureau BIS mostly are coming from IEC. IEC is a global body making say standards, electrical engineering standards for the global use. Out of this, TC64 is a technical committee which is making standards on safety and protection from electric shock. So almost all nations are members in this particular technical committee, and there are hundreds of experts working on this different technical groups. MT3, MT12, these are actually technical groups for various subjects. I am a member in some of the working groups in this particular technical committee. I'm also in the TC81, again, few of the technical committees, plus most of the safety subjects I am in the IEC committee, plus I'm also involved in National Building Code in the electrical committee, also National Electrical Code and so on. So basically, my experience is from the standardization point of view as well as the electrical safety audits. So with this small introduction, let me start the presentation. Actually, fire is a big threat in our country, especially fire due to short circuit. All of you know very well that the number of accidents a lot of accidents are happening across India, especially hospitals. People are dying, children are dying, multi-storied buildings are catching fire. And Bombay, for example, the fire department says about 80% of fire accidents are from electricity. Delhi says about 70% are from electricity, and each city, only the percentage varies here and there. Out of these 80% electrical fire accidents, if we compare, say for example, out of 100 accidents, almost 20 plus accidents are created because of the explosion from air conditioners. So air conditioner is becoming a big subject or a hot subject, which is creating a lot of accidents. But of course, not only air conditioner, our electrical system has something wrong, is what we come to know because of these accidents. If we look at the global scenario, what you are seeing in the picture in the slide is a study report published or presented by a Japanese delegation during 2016 in a seminar at Delhi. So according to them, in India, approximately 723 people are dying due to electrical shock, electrocution out of 100 million population per year. Average 723. In comparison, you can see the other countries. So, say for example, Japan, it's just 12 out of 100 million population per year. And so here actually we are the leader. Probably we are much more than some of the African nations. The same study group, they made a comparison. They made a quiz, a kind of a survey, and they made a safety score. And out of G20 nations, we got the least score. 16%, our electrical installations reliability. This is basically the reliability part is basically from the electrical installations within a consumer premise. So there is something serious about our electrical installation. So I'm going to explain you some of the serious problems which are leading to accidents. First of all, once when we think about the safety, first we need to understand the rules and regulation. All of you know that the rules, for example, at the moment, the current rule is called as Central Electricity Authority Measures Relating to Safety and Electric Supply Regulation 2010. Originally, this regulation has come from the 1956 IE rule, which is not valid now, which has even originated from 1937. The electricity rule. So basically, we have a rule since 1937 for electrical safety. Now the issue is now in 2022, a new draft of this electrical regulations has been published. Probably maybe within 3-4 months, the new regulation also will be coming up. In the new regulation, a lot of misinterpreted subjects has been made very clear so that it is easy for the people to understand. Now, The safety regulation has got a background. The safety regulation is made based on the Electricity Act 2003. And the Electricity Act, for example, Section 146 says, in case of any accident, the owner of the building is responsible. 3 years imprisonment is included in the act. Penalties are included in the act. So basically, in case of any accident, the owner of the property will be technically, there is a big chance that the owner and the responsible people can be put on jail. 3 years imprisonment plus a lot of fine. Now, once when we come to the within the installation, the regulation 12 says all electrical installation within the installation, they shall be as per the code of practice of Bureau of Indian Standards or National Electrical Code of India. Actually, the regulation concentrates much more on the distribution and up to the point of commencement of supply. And inside the building, we are supposed to follow the code of practice of India. But here, actually, the confusion starts. Across India, a lot of electrical engineers think that the word earthing, because electrical safety, earthing is a very important subject because earthing is related to electric shock and sparking and fire. People always think that earthing means two for neutral, two for body. I will explain it later. This is a big misinterpretation. And the electricity supply companies, to my understanding, 10 years, 15 years experience, wherever I am visiting for several audits, the electricity companies, electricity suppliers are not following the regulation. Now, another point, another important subject when we talk about the rules and regulations are, when we talk to the industry, they say that my electrical installation I have designed as per American standard. Somebody says my standard, I am following British standard, I am following German standard. We do all latest things as per the other countries' standard. But just for the information, there are only 3 international standards recognized by the World Trade Organization under TBT agreements. They are ISO, IEC, and ITU. IEC is standing for electrotechnical subjects, and India is a member in the IEC committee. Not only India, all the nations are members of IEC. So the electrical safety rules for global use is made by IEC, which is followed in all the countries. The same rules are followed by all the countries, whereas a lot of time our installations, we try to follow some either private standards, or sometimes we try to follow the standards of some other nations. The main reason for the electrical accidents are actually due to the usage of standards which is not of Indian origin, because these standards originating from other countries have some influence which is locally applicable. So once when we try to follow something which is applicable to, for example, in UK, if we try to follow this in India, actually we are in trouble. So this is absolutely not required. The IEC standard 60364, globally, all nations are following the same standard for electrical safety, same standard for lightning protection, same standard for components, same standard for wiring, and so on. This standard is called as NFPA 70 or NEC of America, BS 7671 as British standard, VD 100 as in Germany, and in India, IS 732. Or it is there is one more code called as National Electrical Code of India. Basically, we have the best standards in India. It is the accidents are not because of non-availability of the documents. The accidents are due to some other issue. I'm just showing you a video which is from a hospital. You can see the portion which is shown on the circle. The nurses started running a little bit. It's an ICU. They are trying to remove the patient from the equipment because they have found something wrong. You also should look. You see, several people are still on the bed connected with a lot of biomedical equipment. There are 4 or 5 patients, and now the equipment started burning. I hope the video is very clear. The equipment started burning. You can find the video in YouTube. This has come in the Times of India last year. And the most important point is within 90 seconds, within 1.5 minutes, this complete room was filled with the thick smoke. That is one part. But the second part, which an electrical engineer always should think, is why this equipment is catching fire. What happened to the protective device? Before catching the fire, the MCB should trip. The purpose of MCB is to trip so that there is no fire accident. But all these accidents, after the accident, what we generally hear is accidents are due to overload, because the wiring is too old. Wiring is designed for connecting 10 equipment, but the client has connected 10 equipment, and because of overload, the fire has started. Technically speaking, this statement, fire due to overload, is a wrong statement, because I request the participants to mute yourself. Now, if you look at
Please
the electrical,
mute all the participants except the speaker. And also, please put off your videos, please. Participants, I request, please put off your videos, except the speaker. No.
yeah,
Yeah.
thank you,
Okay.
sir.
Sorry.
So we should understand that each of our electrical wiring has got protective device. Let's say, for example, in a hospital, there is a transformer, there are protective air circuit breakers, MCCBs, MCBs, fuses, and so many protective devices are there in the circuit. The question to be asked is, once when the ICU equipment is getting hot, becoming hot, before creating a fire, why these protective devices are not disconnecting the supply? Why these are not tripping? If the device didn't trip, of course, the equipment catch fire. So it's very simple to understand. So we should not say that fire is due to overload. We should say that fire is due to non of the protective device. It's very easy. Now, in a properly designed and erected and tested, designed, erected, and tested electrical installation, the chance of fire from electricity is absolutely nil. This is the way. The chance of an accident is very, 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 very little. This is the way the standards are made. For example, the electrical installation in a swimming pool, for example. In the IEC committee, we were discussing for several months with several technical documents to make the standard or to change the existing standard or to improve the existing standard. If those standards are followed properly, the chance of accident is absolutely very, 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 very minimum. But we should start asking, don't say that the fire is due to overload, think that fire is due to non-operation of the protective device. Very easy to understand. Now, what is this disconnection time? The electrical system is designed in such a way that from the transformer, here you can see a transformer, you have the meter board, or that means after the meter board, you start consuming the electricity. Probably you have a public electricity supply, or you have your own transformer. You have the fixed part of the electrical installation. You have the socket outlet devices and so on. Now, at the final circuits, the maximum allowed disconnection time is 0.4 seconds in case of a TN system and 0.2 seconds in case of a TT system. These timings or these disconnection times are established due to in order to provide protection against electric shock. Now, if you look at against electric fire or fire ignited from an electrical installation, even if the time is a little bit higher, even if the equipment is disconnected within 3 seconds, the chance of fire is nil. But anyway, the maximum allowed time, disconnection time, is here. In the fixed part of the installation, TN system 5 seconds, TT system less than 1 second. The most interesting part is What is this TNTT system? Actually, the whole confusion of electrical engineers starts from a subject called system earthing. System earthing means from the transformer, you are taking the electricity through cables, through switchboards, through protective devices, distributing it to your electrical apparatus and consuming the electricity. There are different techniques with which the electricity can be taken from the electricity supply from the transformer and consume it in the electrical installation. And the important subject is called as system earthing. System stands for the source distribution and your connected load. It is classified into TNC, TNS, TNCS, TT, and IT. Unfortunately, even though our standards such as IS 3043, IS 732 has very beautifully explained these systems and its application, most of the time this is a big confusing subject to the customer or to the engineer. And what do we do with the name of earthing? Transformer neutral, two separate copper pipe or copper plate to earth pit, each transformer, each DG has got two strips running and connected to a plate in soil. Body, again two more. Main distribution board, again two more. Lift, again two more. UPS, again two more. Electronic equipment, again two more. Something is called as clean earth, isolated earth, and all these mistakes we start using. The whole story of electrical safety, or the whole method of these accidents, or the reasons, the primary reason for these accidents are due to this kind of an illegal way of earthing. It is never written or never documented in any of the Indian or international standards, but people start following a system which is a big mistake. For joke, I call this as 2 for neutral, 2 for body. That means whenever we talk about earthing, people say, yes, I have a transformer, I have connected the neutral to two numbers of earth pit, body connected to two more earth pit. Please understand that it is completely wrong, and this is the main reason for accident. Number two, a group of equipment like electronic items and UPS connected to separate earth electrode in soil, power earth separate, lightning protection separate. This is also absolutely mistake. Number three, there are separate like clean earth, power earth, lightning protection earth. Then sometimes people are very much proud to say that without informing the electrical inspector, I interconnected everything under the soil. Please note that this is also a foolish idea. This is also never written or never documented in any of the documents in India. These are misinterpretations. What is written is, for example, you are seeing a picture from the IS 3043. Finally, I explained how this earthing is related to fire. Now, in the picture, what you are seeing is a generator, an engine, and an alternator. On the right side, you can see an incoming electricity supply. Earthlink means it is a TNCS network. What you should look at the engine and the alternator. Both are connected to a common bus bar. Neutral of the alternator, from the alternator, it is also connected to the same bus bar. Incoming EB supply, the earth is also connected to the same bus bar. Load side, again connected to the same bus bar. The same bus bar is also connected to extraneous conductive parts. Again, it is also connected to independent earth electrode number 5020 chassis earth. This is how earthing has to be made in whatever the installation is, whether it is a house or residential or hospital or industrial or commercial or hotels or whatever. The meaning of earthing, the only meaning of earthing explained in the standards with pictures are to create an equipotential bonding system. That means all the metal parts in your building except the current carrying conductors such as the phase and neutral must be connected to a common bus bar. As a result, there is no shock voltage. simultaneously accessible metallic parts doesn't carry any voltage. So even though these pictures are shown in the Indian standards since the last 40 years, I am wherever we are going wherever we are doing safety audits, I see only maybe 1 or 2% of the total installation, these kind of the correct proper method of is followed. In all the 98% of the installation, the story 2 for neutral, 2 for body is followed. Now, how this is explained again? I'm showing you a circuit. Starts with a transformer. S is for a source. You have the line means the live conductor ROIB phase through an OCPD through an MCB or a fuse. It goes to a load. The neutral is connected back. Body of the equipment is connected back to the neutral of the source through a separate conductor, and this is called as a TNS system. For industrial and commercial premises, we are supposed to make a TNS system. Whenever there is a fault in the exposed conductive part of your installation, the fault current will flow through the metallic fault return path, through the source, through the phase conductor, and now you have a closed loop. The electricity is flowing through this closed loop. The impedance of this loop decides the amount of the current flowing at that particular time, and the amount of the current decide the disconnection time. Say, for example, you have a 10 amps MCB which is connected to a 1-ton air conditioner, for example. The air conditioner is faulty. Within 0.2 seconds, the MCB should trip. For the MCB to trip, a 10 amps MCB, type C MCB, there are 3 categories of MCB. If it's a type C MCB, it requires minimum 100 amps current to trip within 0.2 seconds. Now the 100 amps current is decided by the impedance of this particular circuit, simple Ohm's law. And these calculations are written in the standard. Now, all electrical engineers follow 2 standards or 1 standard for earthing, IS 3043. And they always claim, for example, if you look at the tenders of government buildings, they always say earthing as per IS 3043, plate earthing, pipe earthing, and all these things. But please understand that IS 3043 is not explaining about plate and pipe. IS 3043 is explaining about how to reduce the fault loop impedance in your network and how to make your MCB efficient to trip during a faulty condition. These calculations are given in the upcoming National Electrical Code. We are trying to simplify it again. We have made the calculation, different type of MCB, what kind of fault loop impedance are desired for each and every case. Now, please understand that both the Code of Practices of India, IS 732, IS 3043, National Electrical Code of India, all these standards, what they say is fault loop impedance shall be calculated during design. Every circuit, you are supposed to calculate the fault loop impedance during design. Fault loop impedance shall be tested during erection and commissioning. Before you connect your equipment, you find out whether your MCB, you have provided an MCB, but whether the MCB will trip or not, you should test. Fault loop impedance shall be checked periodically to ensure safe disconnection of supply. Say, for example, every 2 years, every 3 years, or every 5 years, depending upon the criticality, we are supposed to do the periodic testing. And every electrical safety audit, the first measure to be checked is this parameter called as fault loop impedance, just to ensure that your protective devices are able to trip or not within the desired time. Unfortunately, there is the IS 732 1989, not now, 32, 33 years back, has written in the clause 5 that this fault loop impedance must be tested, and the method of testings are explained, and I think in about 60 plus places in the standard, this the importance of this parameter has been explained. But until now in India, 99.9% of the electrical installation, these tests are never heard of. let me put as not, the test is not made is not the correct word. So many places, this fault loop impedance and an associated test is never heard of. That is the situation for our accidents. The second point, protective equipotential bonding. Every electrical installation, safety is achieved by, or fault protection is achieved by, protective equipotential bonding and automatic disconnection of supply. What does it mean? It means every metallic object in your electrical installation must be interconnected. Say, for example, your building has got exposed conductive parts, means the like a motor, like the sub panel or the current carrying objects are inside. The electricity used equipments have got a body, and whenever there is a fault inside, a person can get electrocuted. So you have the exposed conductive part. You also have extraneous conductive part like the metal pipe, the aluminum frame of glass facade, for example, the rebar of your building. These are extraneous conductive parts. You have to take a bus bar, interconnect the exposed conductive part to MET. This is called as protective earthing. Interconnect the extraneous conductive part to the MET. This is called as protective bonding. Now the MET, in case of a TT system, you have to have one earth electrode in soil. The MET has to be connected to that particular earth electrode, and you should have an RCD for earth fault protection, and this is called as earthing conductor. MET is also connected to some buried metallic items. They are also called as earthing conductor. Now, between at far end of your electrical installation, you also should have a protective measure called as a supplementary equipotential bonding. You can see here, and all these connections together are called as protective equipotential bonding. Every electrical installation, it is a mandatory requirement that protective equipotential bonding must be made. This has been written not now. This has been written in all our standards since probably 40, 50, 60 years. But I always ask my clients, can you show me one metal pipe, let's say, for example, a five-star hotel, metal pipe, the firefighting sprinkler, the metal pipe which is running all around the building. Can you show me one connection with a small piece of wire, let's say a 4 square mm wire to the common bus bar? Most of the cases, it's quite unfortunate that these simple safety measures are not followed. The cost of making this kind of a connection probably is 200 rupees, but for the cost of this 200 rupees worth connection, we lose life. The standards also have written, as I said, there are so many subjects which is there. We are making the Vidyut Surakshit Bharat Abhiyan as a campaign for the last 1 year, little bit more than 1 year. Now it's almost 15 months. We explain a lot of subjects to the electrical engineering fraternity. Now, one of the subject which is of very much important is inspection. As I said, a properly designed, erected and tested electrical installation, chance of an accident is almost nil. Now, what is this testing? Testing consists of 2 points. Inspection consisting of almost 19 points, starting with the method of protection against electric shock, because there are several methods which can be applied in an industry or in a building. So the appropriate safety measures shall be implemented, and the inspector has to verify whether these are correct or not. Now, similarly, there are several inspection points, physical inspection, then the testing. The second part is testing. There are 10 tests included in not only in the Indian standard, worldwide. Of course, in Europe and some of the modern countries, they have added one more test, which is the 11th test called as PAT, Portable Appliance Test. For a low voltage electrical installation, please understand that the majority of the accidents and fire are happening from the low voltage electrical installation. And these tests are mandatory, and this has been included since 1989. As I said, out of these 10 tests, 4 tests are carried out in supply off condition and 5 tests are carried out in supply on condition. I have also put the 11th test called as a PAT, Portable Appliance Test. The concept is, with these 10 tests, you get a very good electrical installation. But tomorrow, if you connect a faulty equipment, this may lead to a fire. That is a test which ensures that the equipment is healthy, or you are not. Before connecting a portable device into your equipment, you have to be just sure that your equipment is in a healthy condition or not. Now, in order to conduct the testing, you are supposed to keep the sequence. In case of any failure in the test, you are supposed to rectify the mistake and you are supposed to redo the test. Then in case of, you have to have several safety measures to carry out these tests. But basically, the simple measure or the simple method which I wanted to tell you or which I wanted to explain is, if these tests are carried out properly and if the mistakes are rectified, the chance of an accident require additional safety measures. Say, for example, sometime for an instrumentation system in an industrial premise, it cannot afford to disconnect the supply in case of a fault. So fundamentally, the electrical supply or the electrical system is classified into two. Earthed system, where the protective device should disconnect the supply before it creates fire or an accident. Unearthed system is possible in critical places where continuity of supply is necessary. That means for an instrumentation system, even under a fault condition, tripping of the power supply will be a problem. It can lead to other accidents. So that critical application, let's say, for example, control supply in a substation, you have to go for an unearthed system. So basically, these additional measures are also necessary depending upon the criticality of your building. Especially for hospitals, the medical equipment and medical systems are classified. There are about 300 plus ISO standards established for each and every equipment, which is a biomedical equipment, which is made and installed in this particular location. The hospital management should look at those standards and buy the equipment which is satisfying those particular standard. Then once when you install those equipment, you have to be careful and you have to follow the rules and regulations which is written in the code of practices. Because once when we make some modification or something in the standard, we are supposed to refer to all the associated subjects. For example, if we write that you have to make a protective equipotential bonding, we have to understand the references from several standards, refer to all the standards, refer the technically published documents, vetted documents, and always try to improve the standard. This is how the systems are working. Medical electrical systems are classified and there are standards already available. The medical electrical system, for example, 62353, every equipment after repair, before connecting it, you are supposed to make a testing. Now, the medical locations are classified into Group 0, Group 1, and Group 2 medical location. Group 2 medical location is a place where the patient is connected with a lot of biomedical equipment. The supply disconnection will create a hazard. So continuity of supply is necessary for that particular area, and a lot of measures are already included in the standard. The touch voltage is 25 volt, and additional tests are also included. Additional test in the sense, as I said, the first 10 tests are for a general location, whereas the additional tests are necessary for special locations. Means wherever you need extra safety, we are supposed to make these additional tests. Now, all these tests and all these informations you can find in the BIS code of practices. And for your information, all the BIS standards and code of practices you can download at free of cost. You go to the website of BIS, or in Google you can search BIS sales portal. Go to the website, create username, password, and you can download all the standards at free of cost. And you can make use of it. But again, going back to my presentation, the First enemy of electrical safety is this concept: 2 for neutral, 2 for body. Please understand that this never existed in our system. This was never written in any document. This kind of, another way of doing earthing, so many earth bits, so many, clean earth, power earth, lightning protection separate, these are wrong. This is also wrong. So the only written method which has to be followed is called as protective equipotential bonding. Means all the metallic parts in your building are interconnected together in such a way that simultaneously accessible metallic parts doesn't carry a shock voltage. As a result, people are safe. In industrial area, if you have functional requirement, such as you have, for example, you have a lot of electronics or you have instrumentation system, those instrumentation system require a functional earthing for its proper working. But again, the functional earthing also must be connected to the protective equipotential bonding system. There is nothing called a separate earth electrode in soil. If you make the separate story, actually we are spoiling our electrical installation. With this, I would like to stop the presentation. Back to one of the presentation again. Please understand that disconnection time, very important. If the disconnection time is maintained very well in an electrical installation, low voltage electrical installation, chance of fire will be almost negligible. The chance is almost 0%. With this, I would like to thank the organizers for giving me an opportunity, and so I stop my presentation. You can also follow me in the. I'm putting a lot of videos in my Facebook and YouTube and the social media. You can get all the information, videos and information in the social media. You can also contact me in case of any clarification on my email and mobile phone. With this, thank you very much, and over to you, sir.
Thank you, sir. Thank you, sir, for this wonderful lecture. Sir, in the chat box, we have received several queries. So I am taking, sir, one by one. Sir, the first query is, what are the methods used to mitigate arc flash in non-arc content HV switchboard?
What, sir? Can you repeat the question?
Yes, sir. Yes, sir. What are the methods used to mitigate arc flash in non-arc content high voltage switchboards?
What are the methods? The first method is the on a live part. Before working on a live part or before accessing a live part, we are supposed to take care of the safety measures. If all the safety measures recommended are made, then the chance of flash is limited. Number one,
Yeah.
avoid working on a live installation.
Yes, sir. Yes, sir. Now, sir, next query is like, how can you do thermography on an operational switchboard?
As I said, sir, I am deadly against this particular thing. For low voltage system, thermography is not included in the standard. So I always say that don't do this thermography. It is not going to help you in any way in a low voltage electrical installation. So please do as per, or please do what is written in the standard first. If you have already made all the tests as per the standards, then of course thermography may not be required. I am against opening a panel board and do thermography internal. I am so sorry for that.
Yes, sir. Now, sir, next query is that in National Building Code, the guidelines for fire protection is provided, which covers for the new building. Is there any standard in India which covers the electrical infrastructure of the old building?
Yes, of course. The IS 732 is existing since 1958, I believe. 1958 or 1961, whatever I explained, it is there in our. These are not new. These are there since 1960s. So then, if somebody asks what to do with the old building, then I will ask back what you did. Have you made it as per the old IS 3043 or IS 732 or the old National Electrical Code? So if it is made, then of course conforming to the new requirement is quite easy because nothing had changed. Only some improvements had happened. So the National Electrical Code of India, for example, it has been published, I think, almost now 25, 30 years now.
Yes, sir. Yes, sir. Now, sir, with your permission, I am taking another question. As there are several questions, but we, due to time constraint, we have to take some more question. So, sir, what is last question is, sir, what is the best practice for the transformer earthing in terms of numbers, and what are the permissible results?
Actually, at the secondary side of the transformer, we are supposed to create a system earthing. Industrial installation means a TNS installation, TNS system earthing, and in case of public electricity distribution, it can be TNCS. That means there is a metallic fault return path. The earth pit, normally people ask what is the preferred earth pit value, earth electrode value. Earth electrode value can be 1 ohm or 10 ohm or 100 ohm. That is not at all going to influence your safety. Let it be 100 ohm, for example. That is not at all going to influence safety. But if you have implemented a protective equipotential bonding in your building, say for example an industrial or a commercial building, you are safe. Now, the transformer system earthing. The current system which we are following is the transformer neutral. Each DG and each transformer are connected to the earth electrode in soil. Of course, for a high voltage system, you have the earth mat, and there is only one way you have to connect to the earth mat and soil. Whereas for low voltage system, the best method is to make the neutral earthing inside the incoming switchboard. For example, the main distribution board, you make a small link between the neutral and the earth bus bar. That's your neutral earthing. And that is what is again recommended in the IS 3043. If you look at the preface, nowadays earthing is used for fixing the voltage of the system neutrals. Means you need to have one connection between the neutral bus bar and the earth bus bar inside your main switchboard. You don't need to. Earthing, as I said, has nothing to do with, or it has little to do with the earth pit in soil.
Yes, sir. Yes, sir. Thank you, sir, for this nice explanation. Now, I would like to invite Professor Krishna to formally provide vote of thanks to our expert speaker. What do you, sir?
Thank you, Savik. Before I give my closing remarks, I ask the participants, I do one or two open questions to the participants. Is there anybody want to ask the speaker directly? I'll unmute all the participants. Savik?
Yes, sir. Yes, sir. Yes, sir. All can unmute themselves.
Anybody want to ask directly to the speaker? You can.
Can you hear me, sir?
Yes.
May I
Sir,
speak?
I have one doubt, sir. Please provide one PDF, sir. Please, we are required, sir.
Speak little loudly.
Sir,
Yeah,
sir, my name is Bangar Naidu from Andhra Pradesh. We are required PDF, sir. PDF. Today, totally enter in electrical safety class. So we required PDF. Further future, we have any participate any programs. This PDF is very important, sir. Please.
Sir, it's already available. It's already available. I will just show you a blog. In there, you can find out all this information. One moment, please. I'm just sharing my screen. I'm sure you are able to see my screen. You can go to a website which is called as vidyutsuraksha.com. vidyutsuraksha.com. I will put the website address in the chat box, so please have a look. Now, in this website, we have put all the, this is the campaign which we are doing. And here there is a blog. On the last, you can see the blog. Not only the videos, each video, for example, if you look this one, lightning protection. This is an 8-hour class taken by Dr. Nagabhushana, the chairman, retired chairman from Indian Institute of Science. Now you can see if you scroll down, this is the session 1, 2.5 hours video on lightning protection, session 2, session 3, session 4, and question answers and the PDFs. Everything is already there on the website. Please go through the website and you can download it yourself. So, thank you very much.
I have one question, sir. Sir, I have
Mr. Gopakumar, I need to speak. I am speaking from Australia, and it is already 11:30. I do apologize, our Indian audience. I have heard Mr. Gopakumar, and thank you for the gentleman who gave chance to the audience. I am feeling frustrated that we have been muted. I asked several questions, and in my mute state, I cannot question anything. So to begin with, I am a practicing principal electrical engineer in Australia in the largest mining company. So what Mr. Gopakumar has said, excellent. But I'm a bit disappointed that he did not highlight on high voltage switchgear on my question. So my first question was about arc flash, and I am the signatory authority of high voltage switchgear. So anybody who does high voltage switching in Australia and New Zealand have to become HVO. So my question was, how do you mitigate and protect your high voltage switchboard from arc flash? Because that is the cause for fire.
Yeah, if you are talking about the fire in an industrial premise, probably the question. But our focus was today mainly for the fire in the buildings and mainly focused on the low voltage part.
Sorry to interrupt, but you can have a 3.3 or 11 kV switchboard in a building as well in the basement.
Yeah. Anyhow, I appreciate your question, but this talk is limited to certain field. That's why you could not take up. Otherwise, the Professor Mr. Gop Kumar is a very, very knowledgeable person. Maybe on some other occasion, we'll bring this high voltage side also. Thank you.
But sir, 11 kV switchgear is also located in a building. So how do you protect the 11 kV switchboard?
Sir, the disconnection times, the expected fault currents, and the relays and the disconnection systems are already documented, and the electrical inspectorates are verifying it almost every electrical installation. Also, the clients are also doing it. But it is a small part of the electrical installation. Also, the statistics say that the fire due to electricity, about only 2% or less than 2% are happening in the high voltage system. Majority are in the low voltage or the other part of the electrical system.
Even in low voltage 415 volt switchboard, what are the arc flash mitigation methods you are using?
Nothing. You disconnect you put an ELCB and you disconnect the supply within 0.2 seconds, so that your problem is gone.
I disagree with you.
Your panel board.
Sorry, with due respect,
and number two, sir, there are devices called AFDD, arc flash device. AFDD is a device. Whenever there is a loose contact in the circuit, the device will trip. They are there in this circuit.
If your cable has formed on a hot joint, it will not. It will create an arc flash, which has happened last week in our system. And what I wanted to hear from you is if you are putting VAMP relay with optical sensors in the low voltage and high voltage cable chamber to disconnect immediately the upstream and the individual section feeder and incomer.
Sir, I am so sorry to say that most of the protective switchgears which is installed in our country, they are not even unable to trip due to a fault current or due to a short circuit current. If they are in a good condition and if it is very highly efficient to disconnect the fault or the short circuit, then as the improved method, yes, of course, the next improvements are possible and it can be implemented. But now The
you are
fundamentals
putting
are
the
missing.
people on risk. The people who are doing the switching operation will be blown away to smithereens. This is what the particularly US, UK, and Australia and New Zealand, they're doing that. You are not supposed to stand in front of the switch gear, and all rack in and rack out is being done remotely through a remote control or through robotic method.
Okay, sir. Okay, sir. Shantanu Kumar, Mr. Shantanu Kumar, thank you very much. You are going into deeper discussions. This is general for general public. You can talk to Mr. Gop Kumar directly. He had given his email, everything.
Yes.
Savik, please mute all the people. Mute all the
Hello.
people.
Yes, sir. Yes, sir.
Hello, sir.
Good
One
evening,
question.
Acha.
Good evening, sir.
Yeah. Mr. Gop Kumar, let me tell you, your talk is an excellent talk. For non-electrical engineers, it's very, very, very useful talk. Maybe for electrical engineers also it is very useful, but I have a big concern as mm, as a I'm also an expert in the safety in the at world level. What I have a big concern, you said 99.9% of the people do not follow the standards. My simple, humble question to you, if a standard is not followed by 99.9%, that means the public is not seeing the value in the standard. And the people who are supposed to control the whole thing, they are tolerant to all these things because they feel it is not required to be followed.